Good evening, everybody. I would like to open by thanking Mr. Vipra Raja, a Medium writer for a writer for Medium, which is a technical document or resource online where this guy really breathes life into otherwise dry academic technical things. Okay, and I'll mention more about him in the description. Now, let's take a look right here. It says, suppose we have p and p+2. Both of these numbers are prime. Okay, this is often called twin primes, okay? But it's thought that there's an infinite number of them, but I don't think that's been proven, okay? But we want to, you can look at what this says. It says p plus p+2 is equal to an integer squared, okay? So I'm going to start out just with a concrete example that would have shown you some of the discovery that was involved in making this claim. We'll prove it deductively, but let's just look at some examples here. Okay, this is equal to 12 squared. So you see this would correspond exactly to this statement right here. For k would be 12. Okay, k would equal 12. Righty. Now the other one I found, which took a little bit longer, is 881. And again, 71 and 73 are prime, and that's easy to determine. Now, this one's a little tougher in my view because you have to establish that 881 and 883 are primes. And actually, you only have to check up through the square root of these numbers, which is less than 29. So you just have to check the primes 23 or less, okay? And you can tell it's not divisible by 2, it's not divisible by 3 by some of the digits, certainly not divisible by 5. And there's a test for 7, 11, and so on, but it's not hard to show that these are prime. Now notice that this is equal to 1764. That's equal to 1764, and that turns out to be a square integer, namely 42 squared. 1764, you can do that in your head pretty easily. 42 times 42 is 1764. Now right here, k is equal to 42. All right. Now notice that 6 divides both of these, which is what we're trying to prove. So this is kind of scant numerical evidence, but d divides both 12. Let me write it like this, just to save a little bit of space here. 12. And I'll just put 42, right? And D is, I should say 6 there, sorry. Okay, that's 6. Okay, 6 divides both 12 and 42, which is consistent with the more general claim that we've written down right here. Okay, so that's what we're actually going to try to do, is prove that k is a multiple of 6. All right. And again, this is part of an article he wrote about twin primes and perfect squares. Now, this is just a p plus p+2 in a factored form is written like this. That's straightforward enough. 2 times p+1 is this object right here. Okay, now, so it's very clear that 2 divides k, right? Already we know we're kind of there. All we need to do is do it for 3. We've just proven, just from the given information without appealing to any deep results, is that 2 must divide k. K is a number, an integer, right? And the left-hand side is even, so obviously 2 has to divide k. There's nothing heavy going on there, okay? Now, now we have to show that if 3 divides k, and we'll be done, okay? Because we were supposed to show that k is a multiple of 6. Okay, let's move along. Now, and a result that's pretty important right here, and I guess I'll reuse k here, but any integer k, not just the k we're talking about here, has this very useful property. It's congruent to either 0, which would make k squared and k a multiple of 3, or 1, right? Notice it can't be congruent to 2 because if you put 2 in here, you get 1 mod 3, okay? And that's very easy to verify, folks. This is super, super simple. When you divide by 3, there's 3 possible remainders, namely 0 or 1. squares can't have a remainder of 2. That's a general statement. A square integer cannot have a remainder of 2 upon division by 3. Okay, so what we're going to do is do a fairly easy. K is not a multiple of 3. Okay, so we'll do that one. If K is not a multiple of 3, okay, then the only possibility is K squared is 1, right? Based on this right here. If K is not a multiple of 3, then K squared has to be congruent to 1, mod 3. Okay, so now this part right here is just a direct substitution. K squared is equal to this, so I just substituted this right here. All right, now notice what, if you divide, if you add 1 to both sides of this, okay, you get this statement right here. In other words, if you add 1 here, you get p plus 1 is congruent to 2, but that implies that p plus 2 is not prime. Okay, well, actually I didn't show you every bit of work on that. If you added 1 to this, you would get, let me just write it directly underneath, folks. Okay, that'll be the best way to do this. If you add 1 here and 1 here, what you can do with congruences, they're much like equalities, you get p plus 2 is congruent to 3 mod 3, right? Okay, but that means it's divisible by, it's not a prime. And remember, p plus 2 is a prime. Okay, so that implies p plus 2 is not prime. So that means K squared can't be congruent to 1 mod 3, which was our original assumption, right? Okay, I hope you're comfortable with this, folks. I just did a simple addition right here. You get p plus 2 is congruent to 3. That means that 3 divides p plus 2, which means p plus 2 can't be a prime, because p equals 1 is not a prime, right? Okay, so K squared is not congruent to 1. That leaves the only possibility of 0, only the possibility of 0, right? But if 3 divides K squared, that implies that 3 divides K. Okay, so these two statements, 2 divides K and 3 divides K, imply that 6 divides K. And that's a completion of the proof. So I'll write QD. Okay, these two conditions we've shown indicate that 6 divides K, and so that does finalize this proof. And again, thank you again. There's a lot more to this. I encourage you to read the article. The gentleman's name is and apologies if I'm mispronouncing, Vipra Raja. It looks like an Indian name to me. Of course, a lot of famous mathematicians of that ethnicity. Okay, Vipra Raja actually wrote an article, and I didn't describe that very well earlier. The name of this online magazine, I guess you call it, is Medium. That's the title of it. It's an online technical magazine, I guess you call it. Science, mathematics, physics, all kinds of things are in it. He's a writer, did a very good job of writing this article, and he talked about this problem in kind of glowing terms. He's not even, the article indicates they're not even sure there's a infinite number. There may just be a finite number of primes and k's that satisfy this. They haven't proven there's an infinite number yet, I don't think. They just know that it happens under certain conditions, but nobody's shown that it happens an infinite number of times. And of course, that's got to be tied to the fact that they haven't proven that there's an infinite number of twin primes also. Okay, but again, thanks again to this gentleman. I love reading that magazine, and I hope you enjoyed this.